Welcome everyone to Jackson-Josephine Small Woodlands Association presentation, Douglas-fir in Trouble, presented by Max Bennett. My name is Jerry Burke and I will be your host. Tonight we will have a presentation. About halfway through, Max will give us an opportunity to pose questions. Please write your questions in the chat window where they'll be read about the middle of the presentation. Speaker Max Bennett has served as an extension forester in Southern Oregon for more than 20 years, with a focus on forest health, wildfire, and small woodlands management. Over the past year, he has worked on a research project exploring the causes and spatial patterns of Douglas-fir mortality in the Klamath Mountain ecoregion. Welcome, Max.
Thanks, Jerry. Well, good evening, everyone. It's exciting to be here. I've been looking forward to doing this presentation for Jackson-Josephine Small Woodlands. So as Jerry mentioned in the introduction, I've been working for the past year, spending a fair amount of time looking at this issue of what I'm calling and others are calling Douglas-fir decline, particularly here in the southwestern Oregon region. And I know this is an issue that a lot of small woodland owners are confronting right now or have been in the past few years. And it's also an issue for a lot of federal land managers, particularly with the BLM here locally. So my remarks tonight are indeed focused on the Oregon portion of the Klamath Mountains ecoregion. I think they may have some relevance for other areas such as Northern California, which I know is experiencing some of the same kinds of issues, and perhaps even up further north into the Willamette Valley and the margins of the valley, where folks are seeing some incipient or some beginning Douglas-fir decline, some mortality. So this is what I'm going to cover in tonight's presentation. I'll start off by talking about basically the scope of the problem and some of the recent mortality trends that we've observed and we can see from the aerial detection survey data. And I'm going to focus on the causes. Some of this will be probably fairly familiar to you, but I think there may be some new ideas or new thoughts that you hopefully will find intriguing. And then we'll, after those first two sections, we'll take a break and answer whatever questions have come up in the first part, and then we'll go on to the rest of the talk. And so at that point, I'll be talking more about management. I'll be talking about how to assess your risk, signs and symptoms of imminent decline, things to look for, some risk mapping tools. I'll talk a bit about strategies for thinning and just sort of managing stands with declining Douglas-fir. You know, what can you do? That's kind of the big question, right? And then I'll finish up with a perhaps somewhat sobering look at what the future holds. So I'm going to start off by just talking a little bit about the aerial detection survey, and we're looking at an image taken of, this is actually, I believe, Ferris Gulch in the Applegate, and I'm guessing there are some folks from the Applegate in this audience. This is taken in the 2016 aerial detection survey, and this is provides a data set that is very helpful when you're looking at kind of large scale mortality patterns. So what they do in the aerial survey, if you're not familiar with it, is you've got a fixed wing aircraft that is traveling along on sort of a predetermined grid pattern, and you've got a couple of experienced forest entomologists and pathologists that are sitting on either side looking out the window, and they are looking for tree problems, for mortality and other sorts of issues, and they're drawing the locations of those areas on a map, and then they are assigning a particular cause to the problem. So for the Douglas-fir mortality that we see, or that they see from the aerial detection survey, it has been attributed to an insect called the flat-headed fir borer. And I suspect that many, if not most of you, have heard of this insect. It's been around, so to speak. And basically since the mid-1970s, the aerial detection survey has attributed the mortality visible from the air to this particular insect agent. One thing that's interesting about the flat-headed fir borer is it's not a bark beetle. It's a lot of the killers, for example, of ponderosa pine and sugar pine and even Douglas-fir in other areas are bark beetles, but this is actually a wood boring insect, and most wood borers are just part of the cleanup crew, at least in conifers. They help recycle the wood and are generally infesting trees that are already dead or close to dead. But the flat-headed fir borer is one of the unusual ones. Okay, so yeah, I was talking about the aerial detection survey, I think, and talking about folks flying along and mapping these polygons of mortality, and how in the aerial detection survey, which is flown, I don't know if I said this, but it's flown generally every summer by the Forest Service and the Oregon Department of Forestry in this kind of joint effort. And the mortality in Douglas fir has been attributed to this insect called the flat-headed fir borer. Okay, so this is a map, kind of a heat map showing areas of mortality from the flat-headed fir borer from 1974 to 2019 based on the aerial survey data. And so the area, the color scheme, the areas in red are kind of areas of greater mortality. So I should say that in the areas that are colored, it does not mean that all the Douglas fir trees were killed. It just means that there was Douglas fir mortality that was mapped in the aerial detection survey. And so what you can see is that there's a lot in close to the Applegate, a little bit in western part of Sam's Valley, and a bit up in Douglas County. But obviously a lot where a lot of you, no doubt, live and have your forests. So it's kind of concentrated in the interior Rogue Valley and some in Douglas County. So I'm just going to show you a few quick slides. You've seen lots of this, of course, but just to kind of set the stage here. So this is Ferris Gulch in the Applegate, 2016. That's the year that things really kind of blew up, and this issue got everyone's attention if it hadn't been already. Trees in all size and age classes seem to be affected, but the majority seem to be in trees in kind of this 80 to 140 year age class. So kind of mature Douglas fir like you see in this image. This is another kind of typical pattern. This is after most of the Douglas fir on a particular hillside have been killed. That's kind of the hillside in the background there. It's a west facing slope, pretty hot and dry. There are lots of trees out there, lots of ponderosa pines and madrone and oaks that are doing fine, but you can see a lot of gray tree crowns, and those are Douglas fir, and most of the Douglas fir on that hillside are dead. This is a mortality patch in the Applegate watershed, not too far from Roosh in the Pilot Joe project, if some of you are familiar with that. So this is a large mortality patch, several acres in extent, and has probably been active, so to speak, for more than a decade and continues to grow in size. These are some trees up by Canyonville. These are some pretty large Douglas fir, greater than 30 inches in diameter at the base, at breast height. Some like this one on kind of the bottom center of the photo that actually probably had pretty good crown ratios in recent times, but they're all fading out of the picture. So here's a time series showing trends from the aerial survey data, the number of trees killed by the flat-headed fir borer from 1974 to 2019. And I see a question that just came up. Is the fir borer native to the area? The answer is yes. It's native to this area and actually has a very wide distribution. So it's found in various places in Oregon and beyond. It's quite widespread. But it seems to be the biggest deal here with Douglas fir. So what you can see from this chart, that the blue bars show the number of trees killed in different years. And you can see that periodically there's been an outbreak for a year or two. But in 2016, that's when things really got very exciting. And actually more than half of the mortality in the 45-year period shown here was just in that last 4 years, 2016 through 2019. So really a dramatic, some sort of threshold seems to have been crossed. So I'm going to talk a little bit about the causes of this decline issue. And I found this Mannion's disease decline spiral to be kind of a useful framework for understanding what's going on. So this is This is sort of a framework for understanding how multiple cascading factors can result in tree death, with the idea that a lot of times it's not just one single cause, but it's multiple causes. So it divides it into predisposing factors, which are kind of the underlying factors, then inciting factors, which you might think of as the triggers of mortality, and then the contributing factors. These are the things that actually, ultimately kill the tree. So for this issue, the fundamental predisposing factor is that these are water stress sites that are at best pretty marginal for Douglas fir under the past climate. I mean, they're fairly close to the lower precipitation limit of where Douglas fir can persist. Then we've had drought, obviously, we're all familiar with that, but increasingly it's been what we might call hot drought, which is drought in association with high temperatures. And that seems to be sort of an accelerant for this decline issue. And then we have contributing factors, so the things that are actually directly killing the tree. And so we've talked a lot about the flat-headed fir borer, and that's clearly a principal agent of mortality, but there are other insects that are involved, as well as some diseases. And there's also abiotic damage. Abiotic meaning not related to an insect or a disease organism. So basically, trees running out of water and experiencing what we call embolisms, or I guess the correct plural is emboli, and emboli. I'll explain what those are a little bit later. So here's that same heat map that I showed before, showing the areas of damage in relation to mean annual precipitation using the 1990 to 2020 normals. So it's divided into 3 precipitation zones, less than 35 inches annually, 35 to 45, and 45 plus. And you can see that a lot of the mortality is in the less than 35-inch zone. Not a big surprise, but this really confirms it. There is mortality in higher precipitation areas, but the bulk of it is in that lower precipitation zone. And so when you actually chart the data, as shown here, you can see that the percent of forest area is the green bar. So that's the percent of the total forest area in the southwestern Oregon landscape. And then the orange bars are the percent of all the trees killed in that 1974 to 2019 period, and the number of Douglas fir trees killed by the flat-headed fir borer. And so you can see, for example, in the 25 to 30-inch precipitation zone, it accounts for about 6% of the area and about 30% of the cumulative mortality, whereas areas over 60 inches of rainfall account for more than 1/3 of the area, or about 1/3 of the area, and less than 5% of the mortality. So there's a pretty clear linear relationship between precipitation and mortality. Higher precipitation, less mortality; lower precipitation, more mortality. This is Elisa's question here is an excellent segue into this very next series of slides that I'm going to show, asking about would Doug fir naturally occur in these areas. So we know, and I think many of you are familiar with the fact that historically there was very frequent wildfire and also human ignitions in the Rogue Valley, on a fire return interval on the order of, let's say 10 years or less in many sites. So very, very frequent fire, and that probably kept the forests less dense, more thinned out. And so one of the ways that we can, sort of one of the clues that we can evaluate to understand that are some of these residual black oak trees. So these are big black oaks in a pretty dense stand of Douglas fir, and you can see several there in the background. And if you look, I guess I don't have a pointer to show you, but you can see kind of some branch indicators on that oak, indicating that it was probably a bit more open grown. And if you kind of go back in your time machine, you can imagine that this was a fairly open stand that was supporting fairly widely spread black oak. But the Douglas fir, with the exclusion of fire, has entered the picture. And this is just another image from another forest showing the same kind of picture. This is an area of Douglas-fir mortality, and you can see this big legacy black oak that was from, originated in a stand that was probably much, much less dense. Now, we have some maps of historic vegetation that have been developed. This is one developed by the Oregon Natural Heritage Program, or a data set that I've used that looks at historic vegetation, historic quote unquote vegetation around 1936, based on General Land Office survey notes and some other historical maps. And so it maps the area in Southwest Oregon in terms of kind of major vegetation types like ponderosa pine and oak savanna. And so these vegetation types included, the dominant species is the name of the type, ponderosa pine, for example, but certainly ponderosa pine type included other species, including Douglas-fir. But the dominant type, the dominant species in that ponderosa pine type was ponderosa pine. So when you overlay the mortality polygons on the historic vegetation, which you can kind of see in the light purple here, and then kind of total up the number of trees killed, you can see that 43% of the flat-headed fir borer mortality was that has been observed was in types that were historically pine and oak dominant. So it's just sort of another bit of evidence to suggest that Douglas-fir has encroached upon and densified in some of these what were formerly more open and more pine and oak dominated types. I'm not saying that there was no Douglas-fir in those types, but the evidence suggests that it was a lot less abundant. Okay, so we've talked about kind of that underlying or predisposing factor of water stress sites, these sites that are just kind of marginal or on the edge. And so now let's talk about drought. And this is something, of course, that we're all talking about and has been in the news a lot lately. Again, I'm showing you a time series of mortality due to the flat-headed fir borer from the Aerial Detection Survey. Those are the blue bars in the bottom. And I have made one assumption there, and that is that the trees were actually killed in the year prior to the year they were detected in the survey. So that big bar in 2015, where over 120,000 trees were estimated killed, that was actually mapped in 2016, but we've assumed that the trees were probably killed the year before, and that seems like a reasonable assumption. So the red line is an index of drought called this, or an index of precipitation called the Standardized Precipitation Index. And basically that's an index that compares the precipitation in a given time period with sort of the historical norm. And the time period could be 3 months long or 5 years long or anything in between. And I have used the 2-year growing season precipitation. So that's kind of comparing precipitation from April 1 to October 30th in 2 consecutive growing seasons. How does that compare to the historical average? And by definition, the historical average, if you look over on that right axis, is 0. So, just kind of like a stock market chart, when it's above 0, that's less droughty, that's good. And when it's below 0, that's more droughty, and that's not so good. And so you can see that generally speaking, droughty periods are associated with upticks in flat-headed fir borer mortality. So something else that's kind of interesting, another factor, and I think I mentioned this earlier, is the possible role of temperature. So this is looking at minimum temperatures during the summer months, June through August, for that time period, and again comparing it to flat-headed fir borer mortality. And what you can see is there was a kind of a big spike in temperatures, not just minimum temperatures, but maximum, average. It was just hot, bloody hot, starting in 2015, and it's been a little up and down, but generally just quite hot for the last several years. So here's another drought index. This is called the Palmer Drought Severity Index. It's been used a lot in tree ring studies, and it takes into account both precipitation and temperature. And as with the previous 2 indices, you can see sort of a relationship between negative PDSI and spikes in flat-headed fir boar mortality. So when the number is negative, that's droughtier. So when you kind of look at these inciting factors in Mannion's framework, so again, we had the predisposing factors and then drought were the inciting factors, we can see that outbreaks of mortality are associated with drought. No big surprise there. But since 2014, the periods of drought have been associated with higher than average temperatures, and mortality has remained quite elevated. And one thing I would say is that the precipitation drought in the 2015 to present period, we've certainly been in a precipitation drought, but it's been up and down, and it's not necessarily historically that unusual. But what is unusual is the combination, or at least in my opinion, what's unusual is the combination of precipitation drought and high temperatures. And Jerry, can you go back one slide, please, just real quickly? So one thing I forgot to mention is that my time series for the flat-headed fir boar ends in 2019 because of the pandemic. There's really not good data for 2020 and 2021, but my weather series goes on. So it doesn't show mortality there in those last couple of years, but there certainly has been plenty. So the point I wanted to make is that the current situation seems quite ominous, really. We have, if you look at those, the historic relationship between those indices and mortality, the indices are about as bad as we've seen them right now. So and we are in fact seeing a ton of mortality out there this year. So one of the things that there was kind of this ad hoc group of folks who has been interested in this problem and assisting with these investigations. And so we were interested in actually looking at trees that were dying or declining and seeing if in fact the flat-headed fir boar was the main thing going on in this tree or these trees, or if there were other things going on. And so we found 3 different sites, one in the Applegate and one in Ashland and one around Gold Hill. And we felled a total of 18 live, that is still green trees, but trees that were declining or appeared to be, on their declining severely or dying. And these were trees that had symptoms like crown thinning or like this woodpecker shaving in this tree you see in the picture. It kind of almost looks like a ponderosa pine, but if you look at the bottom, you can see the gray bark. That is a Douglas-fir that has been infested with the flat-headed fir boar. So we know that tree got hit by the flat-headed fir boar. So we, with this experienced team, including a bunch of pathologists and entomologists, we looked closely at every tree from the roots to the tip and all around it to see what was going on. So the results of our felled tree investigation, we found that the flat-headed fir boar was indeed present on some, but certainly not all of the trees. And typically they were the larger trees. We also found a lot of other insects. We found a lot of round-headed boars, which are typically thought of as part of the cleanup crew in these live green trees, often in association with dead branches at the branch collar of dead branches. We found many other sorts of secondary insects, as well as some cankers, Phomopsis and Dermia canker on many of the declining trees. But on some of the trees that looked very similar to the trees with all these insect and disease agents, we didn't find very much at all in terms of insects and diseases, but the trees were clearly declining and probably going to die soon. So this general pattern suggests that there are probably multiple agents affecting these trees. So it's certainly the flat-headed fir boar. It's probably the biggest single thing, but there certainly looks like there are other things. And I'd call it something like a Douglas-fir decline complex. If you look at this image here, their pen and the 2 arrows are pointing to some pitch pockets. And these probably are from previous unsuccessful flat-headed fir boar attacks. So this tree in this picture was attacked and several times previously, managed to to fend off the flat-headed fir borer, and then finally did succumb to it just this past year. So just a brief segue into thinking about some of these abiotic factors, these non-living factors that affect trees. So when it's really hot and dry out there, trees close their stomata. These are the little openings in the leaves that they use to emit carbon dioxide and emit water vapor, and they close those little openings to reduce water loss, but that results in less photosynthesis. And when there's less photosynthesis, the tree can make fewer defensive compounds, and so they become more vulnerable to insects and pathogens. There's also just the issue of high temperatures, which can increase respiration rates. That's basically the metabolism of the tree, just uses up more energy when it's hotter. The high temperatures can lead to tissue damage. Sometimes there have been cases that have been observed of trees completely shutting down in extremely high temperatures. That is Douglas-fir seedlings here in the Rogue Valley, and not resuming growth until the following year. And then finally, and I'll talk more about this in a second, you can run into this issue where the water conducting tubes of the tree, the tracheids, the straws inside the tree are actually blocked by air bubbles and prevents water from being transported. And that, excuse me, could be a real issue. So in a nutshell, we have issues when it's hot and dry of potential issues of carbon starvation, as it's known, increased vulnerability to insect and diseases, and these embolisms or emboli, which are basically sort of the tree's hydraulic system is starting to fail. Okay, so getting close to kind of the wrap up of the first part of this, the first half of the presentation here. So the possible role of embolisms. As you know, again, thinking about a tree and the water conducting sapwood inside the wood of the tree, the outer wood is basically a series of little tubes, tracheids in the case of conifers, that transport water from the roots up to the leaves. And in some cases, as the tension in the water column in those tubes increases to a certain level, air bubbles may be pulled in, resulting in what's called, in a process called cavitation that results in an embolism. And so actually in that picture on the top there, that kind of squarish thing is a picture of an embolism inside a vessel of some sort of a hardwood tree or hardwood tree branch. And so that when it's blocked by the air bubble, it can't transport water. So we sampled some of the trees that we felled. We sampled branches on them, that branches that were still green, but looked kind of sparse with patchy foliage. And we were curious, do these have embolisms in them? So I won't go into the details of the investigation. It was actually done by somebody, emeritus up Barb Laukenbrook at Oregon State University, who's done a lot of work in tree physiology. And she determined basically that the branches were in fact embolized to a partial to, in some cases, a very large degree. So I think it was like 3% or 3 of the 18 samples had no impairment, and 4 of them had greater than 85% impairment. And so a little bit hard to see in these images, but the purple shading is that's the sapwood in these little branches. The stuff outside, the unpurple ring on the outside, that's the tree's phloem layer. So that's not the wood, actually, that's the inner bark. So the wood in the left sample looks like it's pretty unimpeded using this staining tool, but the one on the right, you can see a lot of white, and that's basically where the stain is not passing through the tubes because they're embolized. And here's just another image of that showing kind of one of the branches that was sampled. You can see it's kind of, it has some dead parts, but also still green. And so the one in the upper left is the embolized branch. The one in the right is the unembolized one. So, we don't know if embolisms are a major factor or a minor factor, there's just a lot we don't know. We don't know how well they can be repaired, and sort of what's the seasonal path. But my own view is that looking at a lot of these large trees, like the ones in this picture taken near Canyonville, large trees that show sort of progressive canopy decline without a lot of obvious signs of insect and disease problems, I think that these embolisms may actually play a pretty significant role in canopy decline. And so it's almost like you could almost think of it as in some cases, maybe it's the main issue and the insects are just kind of coming in to finish it off. Okay, I think that's, so I've kind of covered the scope and the trends and the causes, and now it's time for any questions that folks might have, and kind of take a short pause here, and then we'll move on. Jerry, do you want to just feed out the questions to me, and I'll do my best to respond?
Sure. Alex asks, is there a year lag to see mortality? Are we going to see our trees dying this summer due to heat from last summer? Yes.
I mean, trees that were damaged, let's say last summer, may probably show some signs, but if you're not paying close attention, you may not notice it until this coming summer. Can anything be done to save them? Once they've entered this decline spiral, no, there's not much that can be done. But we'll talk more about in a little bit in the second half. We'll talk more about thinning and how you can sort of more in a preventative vein than in a sort of fixing the problem once it's happened. I think there was another question about moving northward or something. Can you read that, Jerry?
How quickly do you expect this to move northward?
Well, yeah, that's a good question. I mean, I think to some extent the issue is, occurring further north, but to a much lesser degree currently, because areas like the Willamette Valley are just wetter and cooler than southwestern Oregon. On the other hand, the trees there are genetically adapted to more favorable conditions. So it's a good question, and I don't know.
Stan asks, in light of climate change, should we be thinking about planting trees other than Douglas-fir?
Yes, I think we should. And we'll talk more about that. We'll talk more about that later. I mean, I think in a lot of cases, folks are doing, thinning projects in association with, trying to reduce hazardous fuels and improve the health of their stand. In that case, it's like favoring other species that are better adapted to the site now and into the future. And so in some cases that would be, pines and oaks, for example, but we'll cover that some more.
Polianne asks, westward into Curry County.
Are they in Curry County?
Or are these conditions moving westward?
I would say yes, but I'll show you some maps at the end, which kind of portray some of the expected changes. I mean, it's not like a giant spreading infestation so much as it is climatic. As climatic conditions change, the environment for Douglas fir growth changes, right? And so as it gets hotter and drier, and that area of hot and dry goes up in elevation and further north and further west, then more areas are affected. However, I would say that a lot of Curry County is at pretty low risk now, and probably will be at relatively low risk even in the future.
Otto asks, how long would it take a normal or old growth tree to recover, like if there was rain for 14 days? He adds, I've heard that can hold hundreds of gallons of water and cannot suck up that much if there's a good rain.
Yeah, I mean, I think the the trees can hold a lot of water. I'm not sure how much. I think the recovery, I think the decline process is something that oftentimes takes even a period of years. And I think recovery, if it's going to happen, is probably not something that happens just with a couple of rainstorms. It's something that takes a while, just depending on the situation.
Ruth Ann asks, would you recommend replants with Oregon white pine?
Oregon white pine, you mean Western white pine? I'm not sure what species the question is referring to. There is a Western white pine, which is a good species, but that's generally found in kind of higher elevations. So I'd say ponderosa pine and sugar pine are great choices, just depending on the location. I mean, some of the locations are probably, frankly, are just going to are not going to support coniferous vegetation.
Stan asks, once the fir borer enters an area, can actions be taken to minimize the spread? Or what actions can be taken?
Yes. Once they've entered the area, if you're trying to minimize the spread to other Douglas fir trees, it does get tricky. The best bet, I think, is to, and again, it's very site dependent. I think the best bet is to thin, not in a drought situation, which it seems like almost like we're in a permanent drought, but in advance of a drought, while the trees still have a better potential to respond. It's pretty tough to address the problem once things are moving along, once most of the trees are affected.
Elisa asks, are the larger trees that show decline still merchantable as timber?
Yes, trees that are in decline, if they're still green are merchantable if they meet all the other usual, characteristics, sufficiently large and so forth. And then dead trees also continue to have value up to a certain point, depending on the size, maybe up to a year or even beyond that.
Ellen says, Jerry Rayfeld's climate envelope study suggests that Douglas fir, ponderosa pine, and many other species will be severely limited as climate change continues. What other tree species are likely to be threatened by the same mix of responses?
Well, I think any, again, depending on the site, all of the conifers could face issues, and our oaks obviously are probably the most drought and heat tolerant of our local species, and of course there are non-chaparral and other shrub vegetation that will be present. Pacific madrone is pretty drought and heat tolerant, but probably not as much as the oaks. But I think it's pretty. One thing that I'd be a little bit cautious about with this whole thing is being completely broad brush with your species, and I'll explain more about what I mean in a second. But thanks, and we'll be sure to try to get to questions that we didn't answer. Okay, so I'm kind of segueing into a discussion of how you can sort of assess your vulnerability to Douglas fir mortality, and sort of the management side, thinning and those sorts of things. And to sort of set the stage for that, I'll just share that over the past year, with some help from some other local folks, put in a study to look at different environmental stand and individual tree characteristics and how they are associated with Douglas fir decline and mortality. So in other words, trying to understand what factors are associated with a higher risk of mortality, and factors like the slope or the aspect. Is a south-facing or north-facing slope? Does that make a difference? Does the density of the stand make a difference? The tree growth rates, a whole variety of different environmental and individual tree characteristics. and kind of put those all in the hopper and see what comes out as important. And so this study looked at 4 different sites, one up in Canyonville, one near Gold Hill, one in Ashland, and one in the Applegate. We didn't end up doing Ferris Gulch, as is shown in this map. It took about 120 plots, and I'll just show you that we're still looking at the data, but I'll show you some of the things that popped out. So these are risk factors that are associated with a higher likelihood of experiencing mortality. So one of them is heat load or heat load index, and you can just think of that as, you know, the hot, and this no given all we've talked about, there's no surprise here, right? So for example, steep southwest slopes that have the highest level of the highest heat load, the highest level of solar radiation are particularly vulnerable. To contrast that with, for example, a northeasterly slope that is more shaded and does seem to have somewhat lower mortality levels. So another another factor that popped out as important was the presence of Oregon white oak as associated in many cases with Douglas-fir mortality, and certainly not implying that that there's some sort of cause and effect here. We think that oak is sort of an indicator of poor soil water availability. Often Oregon white oak in particular, not so much black oak, but Oregon white oak grows on, you know, it's very drought tolerant, so it can survive in those shallow soils, and so with low water availability. And also we find Oregon white oak growing on soils that have a higher clay content that tend to swell up in the winter and shrink in the summer. And I'm sure you've run into, probably a lot of you have run into these kind of soils. So they just kind of crack dry in the summer, and they're kind of slippery and sticky in the winter. Well, those kind of soils are murder on conifer roots, and especially Douglas-fir roots. So when we see Oregon white oak, I mean, you just so often see Douglas-fir, nearby Douglas-fir appear to be toast. And so I think it's related to the soil factor. Okay, another thing that seemed to be important was proximity to edge. And so by this, I mean just trees growing out on the edge of another kind of habitat, on the edge of a meadow or a pasture or a shrubland, or even a kind of a forest of a different type that has a much lower canopy. So this photo is taken up near Salt Creek up Highway 140. And we think that the reason that edge is important is because, as you might expect, there's a higher heat load on these. There's just more sun exposure, there's more wind, probably more evapotranspiration, higher respiration rates, all just related to heat load. And that seems to be associated with a higher level of mortality. Another factor that may be important here relates to the flat-headed fir borer, because the flat-headed fir borer seems to prefer sunny, open sites. It seems to like the warmth, so to speak, and so seems to be active on forest edges, and actually not to fly very far to its next tree. So we do see this kind of pattern. So on the other sort of side, on the other hand, on the other side of the spectrum, we can think about sites that seem to be relatively protected, at least in the short and medium term, from mortality. And we might even think of these, the term refugia gets thrown around a lot these days. And so these could be sites like this one you can see in the lower right center of the photo, kind of that big patch of green. That's Douglas-fir, often found in sort of lower slopes on northeast aspects, although this happens to be a northwest aspect, and kind of larger patches of larger contiguous patches. And the thought is that maybe the microclimate in the stand interior is it's just less hot and dry. And so the trees in that patch can persist a bit longer, although they get nibbled away on the edges. Okay, so I've taken a crack at developing sort of a numerical rating system. And I'm just showing you this to you as kind of a work in progress, but the idea is that you can look at some of these factors that seem to be important and assign a score to them and total up the score and kind of see what your relative risk level is. So precipitation, heat load, white oak presence, proximity to edge, proximity to other Douglas-fir mortality, and then there are some other additional factors that I'll talk about in a second. And so, for example, 80, if you come up with a total of greater than 80 points, that's very high risk, very likely to encounter Douglas-fir mortality in kind of the 1/10 acre plot that surrounds you, and a very high risk of mortality intensification, versus something that's below 20 points, very low risk of encountering the same. So just a couple of quick examples of this. This is a site that is in a pretty low precipitation zone. So we give it a score of 35. It's kind of a north protected sheltered slope. So a low heat load, doesn't have any white oak, not too far from an edge. So it gets some points there. But it also has kind of moist site indicator vegetation, specifically sword fern and dwarf Oregon grape. And for that reason, I've given in the other, that's what the other factor is. I've taken off 10 points. So it's 35 points. So it's sort of on the high end of the moderate scale. This is another site that is not too far from the one we just looked at, same precipitation, but it's on a steep west-facing slope, has a higher heat load, closer to edge, closer to some other Douglas-fir mortality, and it falls right at the upper end of the high risk range. And in fact, there is a bunch of Douglas-fir mortality right around here. So anyway, I'm not necessarily putting this out as a finished product or anything like this, but I think a tool like this is something that that could be helpful, and a couple of us are going to try to develop it further. Okay, I see your question, Clinton. I'm going to get to that in a second. So just a couple of things to look out for. This is just kind of looking at individual trees and, not, as I say here in the slide, it's bad news if you see these things. So one thing is if you see what we call woodpecker shaving or woodpecker feeding. So like this tree on the left, that's caused by woodpeckers that are feeding on flat-headed fir borer larvae, and they're not actually exposing the wood. In this particular case, they're just kind of eating the outer bark, so the bark kind of looks almost orangey. So that's a bad sign. If your tree looks like that, then it's not, it's going to die. It's not going to recover. Another sort of woodpecker feeding example in the middle, and then on the right side you can see all those holes, and those are probably not, I'm guessing those are probably associated with round-headed borers, but nevertheless they mean that this tree is gone. And so all of these trees actually had green crowns, but they're all going to die. So another thing you can look for in terms of decline is severe recent needle loss, or really a severely fading crown. So it may still be green, but you can just tell that a lot of the foliage is gone, and you can kind of see through it. And I apologize, these are not very good slides, but you can see in each one of these images, you're looking at Douglas-fir crowns, and you can see right through them. They've lost, half or more of their foliage recently. And so that is often a sign of, excuse me, fairly imminent demise. Another sign is what we call chlorosis, which is yellow-green foliage. And also, if you see, like in this tree on the left, you can see it has sort of a rounded top, and its leader growth is very, very minute, and so it's really slowed down in height growth, and so that's another indicator that it's not doing well. Of course, trees that show these symptoms can be affected by other things too. It's not just the Douglas-fir decline complex. There are things like root disease and all kinds of other issues that can account for these symptoms as well. And then finally, things like top kill or branch dieback, sometimes trees that have an abundant cone crop, a kind of small cones near the top of the tree. That can be a stress cone crop that the tree is putting out just before it expires. And then sometimes we have these pitch patterns that seem to be associated with really stressed trees. But as we say sometimes in the forestry world, pitch happens. So it's not always clear that pitch streaming down by itself is diagnostic of this decline and imminent death issue. But if you see a lot of pitch and you see some of these other signs and symptoms, then that's just an additional factor that is not good. So just a couple of interesting things that we've observed about this mortality pattern. And Clint, this gets to your question about riparian. Here's a tree that's basically on the border of a riparian area. And it's kind of located in the bottom of a slope. And, at first glance, I mean, it's a pretty dry site, but at first glance, you might say, oh, that's not too bad of a tree on a fairly good site. But when we look closely at the tree, I don't know how evident it is to you, but you can see kind of in the little sun patch there in the bottom, there are a bunch of those woodpecker shavings. So this tree has been infested by the flat-headed fir borer and it's on its way out. So the thing that we've noticed this year in particular is that, yes, trees on the harsher sites seem to be the most effective, but we're also seeing good trees, relatively good trees also succumbing. And we think perhaps this is due to just the high populations of flat-headed fir borers and perhaps other insects. There are available hosts, and perhaps these trees aren't that, perhaps they've suffered a sharp recent growth decline as well. And this tree, if when you looked at the picture, the first picture, it had a decent crown, but a decent crown ratio, but the top was really round, suggesting that the growth really slowed down. And here's another interesting phenomenon. So also on a lot of these high-risk sites, we have trees like this one in the picture that has it's not a very fast growing tree, but it has a pretty good crown ratio, pretty good amount of foliage on it. It looks pretty healthy. It's kind of what we call a wolf tree sometimes. It has large limbs, looks like it may have grown up in a lower density environment, pretty open grown. And so this tree is surrounded by dead and dying Douglas fir trees, and it appears at this point to be unaffected. And in an area, and I've seen this repeatedly on these, what we would otherwise define as high-risk sites. So I guess my point is that, yeah, there are, a lot of trees are obviously affected, but, I think you really have to look at individual trees, and in some cases, perhaps these large wolfy trees can persist, at least for a while, even while a lot of trees around them are not doing so well. So we shouldn't be quick to always dismiss these sites as not capable of supporting any Douglas fir. So we'll talk a little bit about thinning now, and can thinning improve the ability of Douglas fir to resist these pests and this decline problem? And the short answer is I think so, maybe on the more favorable sites, that is favorable sites within generally a higher risk zone, lower precipitation. So this is a north-facing slope that was in the Applegate that was thinned in 2011. Couple of 2 or 3 years before the drought really started, and there were pretty good leaf trees pretty good Douglas fir leaf trees. They're not great, but decent, that were left in this thinning, and the thinning really favored the pines and the hardwoods, but there were just a lot of Douglas fir to begin with. And so the result of this is that the trees improved in radial growth, and there was very little mortality on this in this particular unit of a couple hundred acres. So in this case, it seemed to work. And here's another example where the same treatment conducted in the same year, not more than 1.5 miles away from the slide I just showed you, did not work so well. This site is experiencing some mortality, and one thing that you can see when you walk around there is some Oregon white oak, and I suspect it's just not quite as good of a site as in the previous stand. And these trees are growing so close to these critical thresholds that it doesn't take much to push them over the edge. Okay, so we're getting close to kind of the end here. So we have a lot of these stands that kind of look like this one. This is up by Canyonville. It's maybe not as apparent, but there are a bunch of big dead Douglas fir in this stand, and a lot of hardwoods and some pines. And this, clearly this forest is a forest in transition. But it's, I think there are a lot of, while tree death can be very distressing, I think there are a lot of opportunities in stands like this, and there are opportunities to thin out some of the declining trees and to favor the hardwoods and the pines, the more drought, the more climate adapted species for this site. And perhaps to leave some dead trees for snags, and and if you've got some good vigorous Douglas fir, and especially the larger ones, hold on to some of those. But you're kind of transitioning these stands, you're kind of giving it a nudge in the direction that it's going to go anyway, but you're doing it in a manner that is perhaps a little bit more beneficial for a lot of goals and a lot of values. Probably a lot of you have heard about the Ashland Forest Resiliency Project, and this is just a shot from that showing harvesting of a Douglas fir tree around a large legacy pine. And it's just an example of the sorts of forest treatments that we're already doing, and a lot of small woodland owners are doing. A lot of thinning and piling and burning and cleaning up and reducing density, and all of that stuff is great, and all of it helps address this Douglas fir decline issue, and helps transition these stands in the face of climate change. And just to go back to one of these big mortality patches, and I just, you look at this picture, and there are, from depending on your interests, your viewpoint, there could be a lot of pros and cons here. So there are a lot of snags, a lot of great wildlife habitat. There's some early cirral habitat, some good wildlife values here. But there's also a substantial accumulation of fuel, large fuel, and the potential for some fairly severe fire effects down the road. So I think, in my view, doing some more preemptive action to capture trees before they die, doesn't have to be every one, but will help reduce some of these problems with fuels accumulation. That's just my opinion. Okay, so I'm gonna wrap it up here with kind of a sobering look at some climate projections. And what I'm going to use for this is a metric called climatic water deficit, or actually climatic water balance. And the reason that I'm showing you this series of maps, and I'm going to show you in this metric, is that it seems to be associated with Douglas fir mortality, in the sense that areas with a very low deficit, and I'll explain exactly what that is in a second, but the green are areas with very low Douglas fir decline, very low Douglas fir mortality, and the areas with red that have Douglas fir are at very, very high risk. So it seems to climatic water balance seems to track pretty well with Douglas-fir decline complex and Douglas-fir mortality. So what is it? It's climatic water balance is a metric that integrates precipitation, temperature, soil water availability, solar radiation, everything that sort of affects plant water availability, and it calculates what's called potential evapotranspiration. That's how much water trees transpire into the atmosphere when water is unlimited, and then the actual evapotranspiration, which is what happens here during the summer when water supplies are, of course, limited. And so when you subtract actual from potential, you get a deficit. And the deficit is measured in millimeters. So very low, less than 250 millimeter deficit, very high, greater than a 400 millimeter deficit. So that's what this means. And this is a spatially explicit, very robust data set that's been developed by the Nature Conservancy and others that's getting some use these days. What I just showed you was the climatic water deficit for the kind of the recent past, and this is the projected climatic water deficit for 2055 under sort of the business as usual climate scenario. For those of you who are familiar with these terms, it's the RCP 8.5 scenario, the kind of the higher emission scenario. So Jerry, let's go back to the previous one again. And you just kind of get a picture here of the different levels of deficit, and then back to the next one again, please. And you can kind of see how that changes. And then let's zoom in to the next slide, please. So this is the kind of the current or recent past, and you can see the Rogue River there. There's Central Point on the left, Grants Pass kind of in the up center, just to the left of center, and then the Applegate Valley. And so that is the current situation. And what you can kind of see is that the deficit tracks pretty closely with topography and with aspect. So the patches of green tend to be at a little bit of higher elevation and on northerly aspects, and the red tend to be southerly aspects and at the bottom of the valley. Okay, and so this is current, and let's look at projected. So that's a pretty, in the interior of the Rogue Valley, that's a pretty dramatic change. And so again, of course, this is just a projection, but what I like about this is it's not, this is just saying what the climatic water deficit is, and then you can interpret this in terms of how different species might do. So for example, I feel pretty confident that above about 375 to 400, Douglas-fir just, it's not only is it susceptible to decline complex, but it'll have a hard time just regenerating and growing to begin with. So you can see a lot of areas are not very hospitable to Doug-fir in this scenario, but that's not to say that it would be completely absent. If you go up a little in elevation and on north slopes, I suspect that's where you see it. And I also suspect that this in some ways is perhaps not terribly different from the historic pattern with more frequent wildfire. I think this is the summary slide. So I'll just kind of run through these, and the first one is the point that I made, that the key predisposing factor is just that mortality is occurring on these very water stressed sites that are pretty close to the threshold, even under a slightly more favorable climate of the recent past. Also, a pretty high percentage of the mortality has occurred on sites where fire exclusion probably has resulted in increased abundance or encroachment of Douglas-fir. Clearly, the mortality problem is associated with drought, and I think what we might call hot drought is playing an increasingly important role. I think that multiple factors are involved here. It's not just the flat-headed fir borer and these embolisms or emboli, whatever they're called, may play a much larger role than has been widely appreciated. We can use some of these tools to assess sort of property level or stand level risk to Douglas-fir mortality or vulnerability. And within some of these high risk zones, thinning can improve Doug-fir mortality resistance, in some cases on some sites with the right timing. But on other high risk sites where Doug-fir viability seems doubtful, it looks like shifting species composition away from Douglas-fir doesn't necessarily mean removing all of them, but just kind of nudging it in the other direction could be a way to go. And then finally, if we don't do anything, I think there are some pretty negative consequences, and one of them I pointed out was the growing fuels issue. So I think that wraps it up, and you've been very patient, and I'm happy to answer whatever questions have come up. So Jerry, fire away.
Okay, so I'll just pick up where we left off. Dennis wants to know if you could discuss the financial impact of growing pine instead of Douglas-fir.
Yeah, just in very general terms, the financial impact is that Douglas-fir is more, has a higher log value, a significantly higher value than ponderosa pine currently. And I don't necessarily see that change. I mean, I'm no expert, but I don't necessarily see that changing. So it is definitely, you know, from a timber management standpoint, that is definitely an issue. But I would point out that, you know, we're focused on the interior of the Rogue Valley, and there are a lot of areas in southwestern Oregon that are less droughty and are currently not really very affected by this issue. So if it's your issue on your property, of course, it's a big issue, but it's not necessarily the same level of issue throughout the region.
John asked something that you may have addressed in a picture. We see perfectly round holes in the bark, 1/8 of an inch in diameter, lots of sap leaking out. The trees tend to die from the top. Is this a sign of a fir borer or sap suckers? That's a beetle.
Well, if the holes are arrayed in kind of a very you know, just kind of in a line or a series of lines, that's probably and they're all about the same size. That's probably a sapsucker, and the sapsucker is not a tree killer. But if you have sort of random holes and varying in size, that's, you know, that's probably insect related, and it's this whole complex thing that I've been talking about.
Jerry asked, once the tree has died, does the flat or leave, does it make any difference if the tree is felled and burned?
No, I mean, once the tree is died, it's probably long since gone. It's like a lot of these bark beetle issues. I mean, theoretically, if you felled the tree when the larvae are inside the tree and burned it, or, you know, piled it and burned it or chipped it up even, perhaps you could prevent the spread of the insect from that particular tree. But you'd really have to do it at a, you know, at a huge landscape scale to really make a difference. So it's pretty challenging. I'm not saying don't try it just to provide some local benefits in your own property, but, you know, understand that the population dynamics make it tough.
Michael asks, are wood borers subject to lower winter temperatures, lower than we've been accustomed to recently? Do they have a mortality temperature window?
It's a good question, and I don't know the answer to that. You know, I know that with, for example, the mountain pine beetle, that warmer winters seem to result in less loss, you know, seem to enhance mountain pine beetle populations. But I don't know if that's the case with these insects, with the flat-headed fir borer.
Paul's wondering if the Douglas-fir trees that turn brown really quickly, like in a month, if that's due to drought or the beetle.
Well, you know, I think it could be, I think it probably is both. It could be a tree that has been under stress for a long time and finally passed a threshold, and the beetle is doing the quick the relatively quick work. But oftentimes trees turn color quickly, but actually they were, damaged months ago, but it was in, they went through the winter and it just wasn't as evident until the following spring.
You may have answered Clint's question, wondering about the effects in riparian areas.
Yeah, like I gave you that example of that one, that one tree that was basically in a riparian area, although actually it was also close to a white oak stand, so it had some other risk factors. I'd say generally riparian areas would be more protected, but in these high risk zones, the very dry zones between 30 or 35 inches, it may not be offering that much protection at this point.
Terry's wondering if you've seen an increase in woodpeckers. I certainly have.
Yeah, yes. In fact, one day I was out there at Collins, and when I was taking the picture of that one tree, there was like a woodpecker banging on a big Douglas fir in all 4 compass quadrants. So yeah.
My pileated woodpeckers are back this year.
Yeah.
Otto is asking, or is wondering if this could be an explosion of pests fueled by drought. Maybe the beetles are reproducing more and therefore overwhelming other trees.
Yeah, one thing that I didn't mention is the local host for the flat-headed fir borer. I can't remember if I said this or not, is Douglas fir. So it's not affecting pines and other species. But yes, Otto, I think potentially populations have built up to the point where it's more a matter of having an available host tree than it is how vigorous the tree is. But I don't think we're entirely sure about that.
Alan adds that the warmer winters are allowing more insects to overwinter successfully, so that the insect populations in the spring are larger. Warming spring and summer enhances rate of development of insects, increasing population sizes.
Great. Thanks for that addition.
Ruth Ann is wondering if you would harvest seeds from these more vigorous and hardy trees.
Yeah, I've wondered about that. And I've wondered about if these more vigorous and hardy trees, if they have a genetic advantage, or it just happens to be, their development as a younger tree. For example, they grew up in a more open grown condition and better captured the site, or is there a genetic difference or both? I don't know, but I think it's an interesting idea.
As a biology teacher, I like Alan's comment about osmosis in trees. I'll let people go ahead and read that. Very interesting. Malcolm's noticed that even age plantation stands seem to fare better than more isolated trees. Is this just a matter of the younger age of the plantations, or is it the stand density?
Well, I think it may be a matter of the size, and I mean, I've noticed that younger trees and in plantations, I think there might be a couple of things going on. One is sort of a micro. Where is the plantation? Is it growing on a favorable north slope? You sort of have to isolate all the different factors that play into that. But yes, I think younger trees don't seem to be as affected as this older Applegate age class, sort of the 80 to 120 year age class seems to be preferentially affected. However, this year, I think we are seeing a lot more damage on younger Douglas fir.
Stan asks a horror question, looking beyond maybe the white oaks and the madrones decades into the future. Do you think the Rogue Valley could become dominated with junipers like Eastern Oregon?
Yeah, I don't know, Stan. Good question. I think that the changes will be significant over time, but I think a lot of our local species, not so much Douglas fir in these harsh sites, but other species will persist. I don't think we need to plant yucca quite yet.
Ruby's asking about the role of pheromones in repelling the insects.
Yeah, pheromones, anti-aggregation pheromones have been useful in the case of the Douglas fir beetle. which is a different insect than we're talking about here. So it's not effective. There isn't one for flat-headed fir borer, and there's one for mountain pine beetle as well.
Michael's wondering if the leader of an evergreen dies back, but the tree still has canopy cover, will a new leader form if the conditions are favorable?
Yes, often one of the side branches will become a new leader. Yes. Mm-hmm.
Paul's asking, what are the assumptions for continued warming for the 2055 scenario?
I'm not sure what, I mean, the assumption is the sort of the business as usual, no, not much of a reduction in emissions scenario. So sort of the higher end of what we typically see. It's a little out of my bailiwick, this that particular question.
Elisa adds that junipers are more prevalent in pumice, well-drained soils, and that the Rogue Valley has more clayey soils.
Great addition. Thank you for that.
Yeah. I think that was the last question. A couple of thanks from the audience.
Okay, well, great. That was a lot of fun. Sorry again about the little snafu, but resourceful Jerry got it working again. So thanks very much. Really enjoyed it, and have fun out there and keep doing great work. And we'll talk to you next time.